So today my group is going to be talking about geothermal energy, which is an energy source that I personally have never heard of or really heard talked about, I think, in science class, or if we did, it was only for a very brief moment. And there's reasons as to why that is that I'll get to. But what is geothermal energy? It's basically what it sounds like. It's energy that is from heat within the earth. And this energy from the earth is a very old heat that comes from deep within the Earth's core. And this heat mainly comes from two sources, which is radioactive elements decaying over time and continental plates that are shifting over one another and causing friction. And so this type of energy is also important because it determines the temperature of matter. And the reason why most people don't hear about it a lot or talk about it a lot is because it's not used a lot, because even though we have a lot of it, so far scientists haven't figured out ways to extract it that are pretty easy in comparison to sources like solar energy or hydropower, which we can use easily and extract easily. So what we do know is that geothermal energy is most currently associated with volcanism, which is just volcanic activity. And whenever this activity occurs, there are large underground heat reservoirs. And when this activity occurs, underground water travels deeper within the Earth's core, and it becomes heated, causing it to flow up and become buoyant. And when it floats up to the Earth's surface, it usually becomes trapped, though it sometimes escapes and causes what most people do know about, which is things like geysers and hot springs. These things have been known for centuries. You can see them at America's national parks. People bathe in the hot springs, and they have for forever. So now we get to how do we convert this stuff into usable energy? And there are two main ways. First, these hydrothermal reservoirs are tapped and wells are created, similar to like with oil. And then the most popular ways that this water is used is to heat it, which can then heat buildings, create power like that. Or what's most well known is to use the steam to generate electricity. And here we have a picture of a hot spring that's in the United States. And here we have an image of an actually newly discovered heat reservoir under Yellowstone. So where are all these power plants at in the world? Well, the major producers are Japan, Italy, Iceland, and US, among a few other countries. Iceland is primed to use it due to its location, which is in the middle of some major continental plates, and there is therefore intense volcanic activity. Iceland uses this geothermal energy to produce electricity for 2/3 of its country's citizens. Another way Iceland uses this energy is by growing most of its produce in greenhouses that are heated by geothermal energy. And here is a picture of one of those greenhouses powered. And here we have a picture of a plant that's located in the United States. So how does the US use geothermal energy? Well, actually, the US is the world's largest producer of it. And the largest in the world is located in California, which provides electricity for 1.7 million homes. There are plants located all along the Midwest and in Hawaii and Alaska. Here is a map of the US showing where all of the power plants are located. So how does Alabama use geothermal energy? Well, we don't. All of the plants that use geothermal energy in the US are located well beyond the southern hemisphere of our country. However, I did come across on Alabama Power's website some lengthy descriptions of it, ways that it's used, just some informative stuff. And it appears that the company that owns Alabama Power did buy shares in a plant in Hawaii, I guess just to make more money. But that is the only connection that I could find to geothermal energy in Alabama. So what are some pros and cons environmentally to geothermal energy use? Well, the number one pro is that geothermal energy use gives off way less air pollutants than any other conventional fossil fuels, and this is a great thing. However, there is one major con to using geothermal energy, and that is that it gives off extreme levels of hydrogen sulfide. This hydrogen sulfide comes from the dissolved minerals or salt in the hot water or steam. And at times, at plants in the US and across the world, this level can get so high that mitigation is required to meet air quality standards. Another smaller concern is that sometimes, this is very rare that it has occurred, surrounding land at geothermal hotspots and near plants may subside or sink into the water from reservoirs and hot springs that are being removed. But again, this is a very rare thing that happens, so it's a very small concern.
Hi, my name is Kazia Taylor, and in this presentation, I'll be discussing the increase and decrease of usage of geothermal energy, as well as some innovations in technology of geothermal energy. So, geothermal energy has increasingly been used to heat and cool commercial and residential buildings. Most geothermal pumps are in pipes underground, which contain circulating fluids to exact natural heat in the winter months, which helps to keep us warm, and transfers excess heat underground in the summer, which helps to keep us cooler. These heating pumps can also be modified to provide areas with warm and hot water. So because of these contributions to our daily way of life, geothermal energy is still widely used. The Environmental Protection Agency even suggests that geothermal energy is the most efficient heating system since it produces the lowest carbon dioxide emissions into the environment. In 2016, the U.S. Department of Energy published their annual report for the Office of Geothermal Technology, and they found that geothermal wells and new geothermal drilling techniques are advancing the technology of using geothermal energy. So, to overcome challenges of drilling for geothermal energy, because when you're drilling for geothermal energy, it can be very dangerous, and the people doing the job are just exposed to a lot of chemicals, wild excess temperatures, and it's just a very dangerous job to have. So contributor Baker Hughes has developed an advanced drilling system designed for critical conditions. This technology can drill directionally at extremely high temperatures up to 572 degrees Fahrenheit, which is crazy dangerous for somebody to be that close to. So the fact that they have a new drill to help them do this and exposed to this temperature is really great. So by using a high temperature lubricant in the drilling fluid, a full metal drill bit to break the formation, and a full metal drilling motor known in the drilling industry as metal to metal motor, the results of this new technology saves in cost, it is easier, and it helps our environment by reducing greenhouse gas emissions. So that is all I have to say about the increase or decrease of use in geothermal energy and the innovations and technology of geothermal energy.
Here, as Kazia had previously mentioned, we have a visual of a pump that is being used to power this building. And here we have a visual of a binary geothermal power plant.
So with the legislation in the 1970s, 74 to be exact, the U.S. government enacted the Geothermal Energy Research, Development, and Demonstration Act, which instituted the Geothermal Loan Guarantee Program, and it provided investment security to public and private sectors using developing technologies to exploit geothermal resources. So that was pretty much just giving people the kind of people feel safe to go out and actually do some geothermal experimenting and maybe actually figure out a way to use it. And in 1994, 20 years later after that, the first act, the government put in a few efforts to promote the use of geothermal energy and to try and reduce the greenhouse gas emissions. And with that, there was two efforts, really big efforts. One was directed towards the development of geothermal resources for electric power generation, and the other was aimed towards the accelerated use of geothermal heat pumps. And so that's really the two biggest things I found on legislation. With tax incentives, the federal tax credit initially allowed homeowners to claim about 30% of the amount they spent on purchasing and installing a geothermal heat pump system for their federal income taxes. So I think that ties back into legislation when one of the main efforts by the government was to help towards the use was to help accelerate the use of geothermal heat pumps. And then the initial federal investment tax credit was a part of the Energy Policy Act of 2005. This bill was passed to help solve energy problems and provide tax incentives for existing and new types of energy production, the main ones being wind and solar. Other than that, I mean, the tax credit is actually decreasing throughout the years, which I think that plays into the next thing of why it's not very popular. And it's not very popular because it can only be found and used in certain places of the world that have the high heat flow and favorable hydrology, which is needed to produce geothermal energy. And since only a few places actually are able to produce those two combinations of things, the most highly populated parts of the world are not able to rely on geothermal energy, and it's not really a realistic choice for people to use it. So that makes things like solar and wind power more reliable for other people and other places that don't have the volcanic activity that we talked about earlier in these other slides and stuff like that. So yeah, that's about it on that.